Hey everyone, um, let's start another lecture of CS2505, and from today we are going to get into the hardest part of C, which is pointers. Pointers is by far the hardest concept you are going to face, and it's best if you pay most of your attention in this one because being a C programmer is all about knowing how pointers work, because pointers give you way too much power and you can do lots of stuff, and most of the other languages do not have this. And with great power comes great responsibility. So when you are working with pointer, you also have to make sure that you do not end up making memory leaks, because having memory leaks while working with pointers is definitely one of the biggest problems. So you have power over the whole heap address of memory, but you also have to be cautious about, like using it, because if you have memory leaks, well, many things are going to happen. For example, I already gave the example of Bloodborne, in which case if you left the game at the beginning when the game released, if you left the game open for 12 hours, most of the enemies stopped working just because the memory leaks made it hard for the game to actually make the enemies move, because they do not have enough memory to process the commands and stuff. So that's the biggest problem of, like, one of the biggest problems of memory leaks. So you have to understand how memories work and how to make sure that there is no memory leak. So yeah, let's get started. So at first we are going to take a look at memories and addresses. So memory is just a sequence of bite-sized storage devices. The bytes are assigned numeric addresses starting with 0, just like indexing of the cell of an array. It is the job of the operating system to manage the allocation of memory to process, keep track of what particular addresses each process is allowed to access, and how to reserve, like, and how. Then their job is to reserve portion of memory exclusive for use by the OS, enforce protection of the memory space of each process and of the OS itself, do all it efficiently as possible, as efficiently as possible. So these concepts are, like, will make more sense to you if you ever take the operating system course. So if I want to give an overview, so how it works is your memory is basically your RAM. Okay, so RAM has like dedicated place for your OS, so it like runs all of the stuff that is important to the OS. So if you ever open your task manager, or in Linux, if you use the command top, I don't know what to do in Mac OS because I do not have a MacBook. So if you do that, you will see that there are some under the name system. So that system is basically what is allocated for the OS. That part you cannot use at all. And for Windows, it is kind of a bloatware. So what happens is it takes way too much memory, and in that part, so even if you have like memory of 8 GB, 2 or 3 GB are like dedicated just for the OS. For Linux, it's like 500 megabyte or something like that. And in video game consoles, it is even less. Like it uses way too less memory for the OS. That's why that's the, like, one of the optimization they do to make video games run much better in consoles than PC, because you know that most of the time PCs are much stronger than the console, but the game sometimes do not work as efficiently. I mean, if you have way too good of a PC, then it doesn't matter. But the thing is, like, why does the difference exist? It's because of the optimization. Because when you are using a PC or something like that, a lot of memory is allocated for the OS, and most of the stuff is like rest of the stuff is used for the other programs you're going to run. But in like console or stuff, they try to dedicate most of the stuff to the console, like to the game, and that's why the games work much better in a console than in a equivalent specs of a PC. That's just something I wanted to let you know, like as a CS, well, not just CS major, if you are going through like any CS course, you should know about this stuff when we are going through that, because we are like talking about memory. So you should know how RAMs work. Okay, so OS has some dedicated part. Rest of the stuff are for programs, and they are also divided on which program are being used. There is context switching and stuff, and in this stuff there is heap, which is usually allocated for the programs to be run, and programs can make use of those memory locations, nothing beyond that. And there are memories that you cannot access. Those are also dedicated for OS. So if you like do something with them, like mess up with them, your PC might crash and something like that. So all of this work is dedicated for OS, and you will learn more about it in the operating system. So the concept of pointer is whenever you are using a program, like you are running a program, you have a whole like heap space. Okay, so what pointer does is it works with the heap space or whatever addresses are available for that specific program. So a pointer is a variable whose value is the memory address. That memory address points to somewhere in the RAM or memory. We are going to refer to the RAM as memory because that's the convention. You can call it RAM if you want, but it's the memory, okay? So a variable whose value is the memory address. Pointy is a value in the memory whose address is stored in a pointer. We say that pointy is the target of the pointer, okay? So imagine this is part of your RAM, and this is the memory address. Okay, so in this memory address, we have a variable called A, which has the value 42. But in this memory address, we have a pointer which points to this memory address. And if we refer to that memory address, we get the value 42. And over here, we have another memory address, C, which holds the address this. And if we refer to that, we get this. And if we refer to that, we get this value. So this is how pointer works in general. This is the basic concept of pointer. You have, like, I hope that made sense. It's basically like whenever there is some sort of like variable or something, you have to understand that that variable has a address stored somewhere. And that somewhere is the pointer. And pointy is the variable you have. So whatever the pointer points to is the pointee. So pointer concepts. Since memory addresses are essentially just integer values, pointers are the same width as the integers. A pointer has a type, which is related to the type of its target. Pointer types are simple. There is no automatic initialization. So first of all, the memory addresses. So this one actually is very important for the 32-bit and 64-bit, because if you have a 32-bit PC, your memory address can only hold an integer of the size 32-bit. And if you are using a 64-bit PC, then it's going to use a memory address of 64-bit. So if you have a 32-bit machine and you are using RAM of like 16 giga or something like that, you can only use 4 giga of it, because 32-bit can only refer to 4 giga. And that's why you should switch to 64-bit whenever you can. I mean, unless you already didn't do it. So yeah, because 64-bit manages to refer to more memory addresses, and 32-bit can only point to 4 gigabyte of RAM. So that's why if you are using a 32-bit machine, like a 32-bit operating system, then rest of your RAM are not being used. A pointer may or may not logically point to a logical valid target. So a pointer may not always point to a target that already exists. It may point to somewhere where you do not have access to, or memory wasn't allocated to. Given a pointer that has a valid target, the target may be accessed by dereferencing the pointer. This dereferencing is a very important word. I will be saying that for the rest of this course probably. So yeah, be ready. A pointee may be the target of more than one pointer at the same time. Pointers may be assigned and compared for equality using the usual operator. You can just use this or this or this. All of them work for pointer, but maybe not the way you think of them may work. Pointers may also be manipulated by incrementing or decrementing, although doing so is only safe under the precisely defined circumstances. We'll be looking at that as well. By convention, pointers without target should be set to 0 or null. This is a convention. It will not always follow that. Sometimes it may point to somewhere it shouldn't be, and it is your duty as a programmer to make sure that a pointer which is not pointing to something should be pointing to 0. So this is how a pointer like syntax looks like. So this is how you declare a pointer: int, then a star. You have seen this star in the string lecture, so now this star will make more sense. And then p1. So it means p1 is a pointer of integer and it is pointing to null. Okay, character star p2. So over here you can see that there is a space after the star, and in this case there is a space before the star. It doesn't matter where the space is, you just have to make sure that there is a space between character and p2, and within that space you can put the pointer wherever you want. You can put it right after the character, or you can put it right before the variable name. It doesn't matter, both of them work. And in this case p2 is a pointer of character type and it is pointing to 0. Okay, so now we have another one. This is a syntax of pointer to a pointer. Okay, it will make more sense to you or maybe not, but I will try my best. So this p3 is a pointer of an integer, and it is pointing to null for now. Okay, so if you want to do in one syntax, you have to make sure that if you want to put them in the same line or same declaration, in that case, you have to make sure that there is no space between the pointer and the integer, and then you can name the variables one by one. But if you have any space, make sure that you have the pointer with all of the variables. Both of them work, it's up to you which one you want to use. Okay, so give this one a try. It might be declared as an integer and not a pointer, again because there is a space. So what I said was probably wrong. Give this one a try by yourself, try to run it by yourself and see whether qt is a pointer or a integer. Okay, sometimes this type of declaration make problems in your program. This is my preferred one. I always do that. I actually make sure that I always have like pointer before all the variables I'm going to use. So I do not usually run into this specific problem. So if you want to declare them in one go, try to do this one and not this one, because this one may not work, or maybe in this case qt can be declared as an integer. Give it a try by yourself and see what happens. It might be in the exam. So address of operator. So %x, you have been using %x since the time you have seen scanf. So now you know that you are actually using pointers whenever you're using scanf. So %x returns the address of the object x, the address of an operator. This is the address of operator. Okay, so whenever you are using %, you are basically getting the address of that specific variable, and that's why it is important in scanf. Why? We will see shortly. Okay, so let's take a look at this small code. So we have integer x equal to 42 and y equal to 99. So we are getting a pointer which is pointing to the address of x. Okay, so p1 is now pointing to the address of x. Okay, address of x. This is very important because you will be working with the addresses a lot from now on. And p2 is pointing to the address of y. Okay, so to get the address, we put the ampersand. So this is how we get the address of x or address of y. And to get the address of a pointer, we use pointer of pointer, because P3 is supposed to be pointing to something which points to something else. And to get that, we use this. You can also write something like this. This is also valid. It's up to you whether you want to do that or not. Okay. So let's look at let's take a look at the visualization. So how it's working is, x is a variable. It is stored somewhere. For example, it is stored at 1, and the next one is going to be stored at after 8 spaces. So like this, and I don't know how to count, so I'm going to just write 1 1, and then it's going to be 1 9 and something like that. Okay, so when we are declaring x, it is being saved in a location like this, and if we do this part ampersand x, we get this value. Okay, and by doing p equals that, we are putting that value over here. Same goes for y. Whenever we are using ampersand y, we are getting this address. And then by doing p2 equal to ampersand y, we are getting this value and putting it here. Same goes for p3. Okay, try to run this by yourself, try to print the values, and if you want to print a pointer, you should be using %e. Okay, give it a try by yourself and see what the addresses look like, and most of the time the addresses are going to be different. Okay, so dereference operator. So the star is going to be called a dereference operator. So what is going to happen is star p names the target of the pointer p, the dereference operator. So if you have a pointer and if you use the star, it's going to give you the value that it points to, or it is going to give you the value of the point t. Okay, so let's take a look at this code again. Again, all of these codes are given in GitHub, so you can run it by yourself, you can write it by yourself. I highly recommend running this by yourself, just so that you get a feel of it. Okay, so integer x equal to 42, y equal to 99. So we are declaring the pointers again. This is just like the previous code. Now we are going to get a integer value. Over here, AA is getting the value which is dereferenced by P1. So we know that P1 points to the address of X. So by doing this dereference, we are telling the compiler that we need the value that is P1 is pointing to. In this case, P1 is pointing to X. So we get the value that X has, which is 42. So over here, AA has the value 42. If we put this, we are dereferencing to the variable. So in this case, P1 is pointing to X. And at that time, X has the value 42. Now we are going to change the value of 42 and make it 10. Try printing the value of X over here and see what happens. Okay, it is going to be the value for 20 instead of 42, because we are changing the value through a pointer. By doing the dereferencing, we are actually referencing to the variable itself. Okay, so let's get another variable, which is bb, which is pointing to the value, the pointer of p3. This is not going to work because over here bb is the type int, but p3 has the type pointer of pointer. So by dereferencing, we are actually pointing to a pointer, but then there is going to be a mismatch of type, and the compiler is going to give you an error telling you that it's not allowed. Give it a try by yourself and see what happens, because you need to get used to that warning or error, because you might be facing that a lot whenever you are working with pointers. So whenever you are working with pointers, make sure that left side and right side has the same type. In this case, there is a mismatch because the left one is just an integer, but the right one is a pointer of integer. Okay, p3 itself is a pointer of integer. So this is very important. So if you want to actually get the value that p3 is pointing to, and then the p2 is pointing to, you have to use double dereference. Okay, this is very important. Give it a try by yourself and see how it works or looks like. So In this case, we have a variable z equals 42, and then we are getting a pointer which points to the address of z. So now if we ever dereference x, we get the value 42 because that is the value of the pointer. So over here, x refers to x and its type is int pointer. Over here, if we do %x, we are basically getting the address of x, which is pointer of a pointer, and it is the type of int pointer of pointer. If we do dereferencing, we get the value of the pointee, which is z's value, okay? And that one has the type of integer. If we do this, it refers to the target of address of x, which just basically means x itself, because first we are getting the address of x, then we are dereferencing it. So basically we're getting to the address, and then the address is going back to the pointee, which is x itself. And then we have x dereferencing, which is z, and then we are getting a address of z, okay? So it refers to the address of target of x, which is just the value of x. Only makes sense syntactically if x is a pointer. If x is not a pointer, it's going to give you a compile error or something, a runtime error or something like that. So in this case, these two are kind of equivalent. But if you really want to mess with your partners or whoever you are working with in a C project, do not use any of this, okay? These are kind of confusing and it catches you off guard most of the time. Let's take a look at another example. I think you already have seen this example. Try to run it by yourself. Try to print the values just to have a better understanding of it, because in the slide I didn't write the print statement, or in the code I didn't write print statement, because I know the value of it. But give it a try yourself, change the values and see how they are looking like, okay? And also try to print the pointers themselves so that you can understand what an address looks like. It is usually going to be a 32-bit or 64-bit address. It is going to be a hexadecimal number. So looking at that, you have, like, whenever you see a hexadecimal number that is a 32-bit or 64-bit, you have to understand that that is an address most of the time, okay? Again, we have went through this, but let's overview it. So we have two variables, and when we are declaring a pointer, we are getting the address of x over here. So P1 is pointing to the address of x, and if we dereference it, we get the value of x, okay? We are doing the same for P2, which is pointing to the address of y. Then we are getting a pointer of pointer, which is pointing to P2. Then we are getting the value of P1 being dereferenced, which is basically x, which is basically the value 42. So AA has the value of 42. And now we are changing the value of 42, and it's going to be 10, because P1 refers to x, and x is this variable, okay? And if we want to get the value that is pointing by P3, which is pointed by P2, which is the y, we do double referencing. Try to run this by yourself, try to change it a little bit just to get a hang of it. So yeah, I already explained all of this. So let's just take a look at how they look. I'm going to go through them again and again just so that you can understand the concept of it, because like I said, pointer is so far the hardest concept of C to understand. So if you do not understand it yet, do not feel bad. That happens to most of the people. If you, after the whole pointer lecture, like there's going to be like 2 or 3 of them, if you still do not understand, let me know. I will try to explain it much easierly with more examples so that you get a hang of it, because pointer is definitely the, well, one of the hardest part of C, and it is kind of a special thing to see. No other languages have the concept of pointer like that, okay? With working with pointer, you basically have way too much power than any Jedi has ever imagined, okay? So over here, ampersand x is the address of x. X is an integer. Ampersand x is the type of integer star. It is important whenever you are getting type mismatch. And ampersand y basically means the address of y. In this case, ampersand p2 basically means the address of p2. It is not referring to y itself, okay? p2 is a type of integer star because we know that we declared p2 as a pointer, okay? And then this is going to be a integer star because it is a pointer of a pointer. In this case, we are dereferencing P1, which is the target of P1, which is X in this case. P1 points to X. X is the value of 42. Now AA is going to be the value of 42. The value of P1 is the value of target of P1, which is the value of X, which is 42. So it's kind of like this. P1 is this. When you dereference it, you are basically going to the place where it is pointing to, which is X, which is the value of 42. And if you put a ampersand over here, and for example, if we have P3, this is what it refers to. So this is the idea whenever you are working with pointer and you are kind of lost, try drawing boxes and try to draw all of them one by one, so it makes more sense to you. So we have the BB, in which case like star P3 is dereferencing P3. P3 is pointing to P2. P2 points to Y. Y has the value of 99. So another concept, pointer comparison. So remember in the array, I said that in C, you cannot actually do like array A equal to array B, because whenever you are doing that, you are actually doing a pointer comparison, okay? So P1 equals P2. What does it mean? Do P1 and P2 have the same target? So what it means is you have a pointer P1 and you have a pointer P2. Whether these two memory addresses are the same thing. That's what you are actually trying here. You are not trying their content. If you want to compare their content, you have to dereference them, okay? So if you are using pointers and if you're trying to see whether they are the same thing, it will only work if you have something like this: int P1 equals like A, and then int P2 equals P1. In this case, if you try this, it's going to work. Otherwise, it's always going to give you false because they are not the same thing. Okay, this is a very important concept. You have to make sure that you understand it. So, sorry about that. P1 is less than P2. So it means like, does P1 point to something below P2? It's not maybe what you're thinking it is. So how it works is, whenever you allocate memories, they are kind of allocated line by line. So this is OX1, this is OX9, this is 11, this is 19, and so on. Okay, so for example, P1 is pointing over here and P2 is pointing over here. So in this case, P1 less than P2 is going to make sense because they are side by side. But if P2 is literally pointing to somewhere else and you are trying to do some sort of comparison, that one doesn't make much sense. Usually you will be doing a comparison like this whenever you are working with an array or a string or something like that. Otherwise, most of the time it won't make sense, okay? So make sure whenever you are doing a pointer comparison, make sure you're working with the same array. In that case, it kind of makes sense. Otherwise, dereferencing, it makes most of the sense, okay? So now why the pointers are necessary. So far you have learned that in functions, pointer cannot do call by value. Most of the time it is called by, sorry. Whenever you are working with a primitive type, you cannot do call by reference like Java. Well, Java also does call by value when you are doing a primitive type, but when you are working with a class, it does a call by reference. But in C, most of the time, it is a call by value. to make it call by reference, you have to use pointers. Okay, so let's take a look at this specific code. We have a variable x and y, and we want to do some sort of swap. Okay, so to do the swap, we are actually sending the address and not the variable itself. And over here you can see that they are the type of pointer, like uint32 pointer. Okay, whatever changes you make in this function is going to happen over here. So after this function has been called, if you try to print x and y, you will see that their values has been exchanged. So what happens is, whenever you're using pointers as parameters, they are actually making changes to the values themselves, because right now you're working with the address, and by dereferencing it, you are actually going to that actual variable, not a copy of it. And that's why whenever you're using pointer as a parameter, it is a call by reference or call by pointer and not a call by value. The pass by pointer protocol provides a called function with the ability to modify the value of caller's variable. Give it a try yourself, change it a little bit, just so that you get a hang of it. Okay. Evil, dangling pointers and aliases. The most common source of errors with direct pointers use is to dereference a pointer that does not have a value, like value. So right now you are making something like this and you are trying to put 42 somewhere, but A does not refer to anything else. So it is going to give you an error that it does not exist. Even if you do something like A points to null and you are checking this, so it is also not going to work, because null basically means it does not exist. Okay, give it a try by yourself. So if you want to have a pointer that points to not a variable but a memory location, you should be doing malloc. Malloc basically allocates a memory, and then you are getting that memory and pointing it by A over here. So whenever you are calling malloc with the size of int, so this is kind of a syntax. So size of int basically is telling the compiler that I need a chunk of memory location for one integer. Okay, so if you want multiple chunk of integer, which is an array, in that case you actually do a size into size of int, which we have seen in the string lecture. I hope now it's making more sense to you. So the size of int is basically telling the compiler that I need enough space for one integer. So what happens is, this is your memory, heap memory, and somewhere this part you are getting the size of int, this much of a allocation. And by doing A star equals that, now A is pointing to over here. Okay, so now you can actually make use of that memory. Now you have another pointer which points to whatever A is pointing, so they are both pointing to the same location. And if you do free A, which is basically means that you are removing this memory location from existence, and if you try to use it with B, it will not work, because that memory location ceased to exist whenever you used free. We will look at malloc and free more closely in the next lecture, but it is just an introduction to it. Okay. So there are other errors like that, like for example, if you try to do this, in this case, A does not exist. Like in the first one, A does not exist. Even if you check for it, it's not going to work, because usually it has a random value or a garbage value. If you try to use this, it's not going to be true, because you didn't specify that A equals to null. In that case, it's going to give you an error. Try to run it by yourself and see what happens. In this case, it's going to work, because like whenever you're calling the f from somewhere, you're actually specifying a value or something like that. So in that case, it's going to make more sense. It is kind of like the swap. Okay, whatever value you are sending, or whatever the address of the value you are sending over here, that one is going to be changed. After this function, its new value is going to be 42. Give it a try by yourself. Pointer and raw memory. Suppose that we have a region of memory initialized as shown below, and a pointer P whose target is the first byte of the region. Okay, then P, like over here we are using P8 and it is pointing over here. So if we try to dereference it, we get the value this. Okay, and if we try to okay, so this is something of a typecasting. So you already know how typecasting works. You have learned that in Java. So I didn't get more into it, but in pointer, it kind of works in a different way. So what happens is, for example, we have these memories, right? And imagine we have the value 42, 43, 45, 49, something like that. Okay. So by doing dereference P8, it is going to point to this memory address and show you whatever value there is. And how it works is, how to explain it? Okay, so how it works is, this pointer is pointing to a memory chunk of 8 bits or 1 byte. Okay, so at one time, it's going to only point to 1 byte. But if you're using UNT 16, in that case, it's going to point to 2 bytes at the same time. So in this case, the value is going to be a combination of these two. Okay. So that's how it works. Like whenever you do a typecasting or change the type of the pointer, this is what's going to happen. Now, suppose that we have a region of memory initialized as shown below, and the pointer P whose target is the first byte of the region. Okay, then we can apply a typecast to pointer P to access 2 bytes. So we are basically doing a typecasting, and in that case, it's going to point to 2 of them at the same time. Sorry, I went ahead of myself. Sometimes it is hard to remember like what made sense to me and what made sense to the students. I'm really sorry. So what I was trying to refer to as is, so first it is going to point to only 1 byte. Okay, but this one points to 2 bytes. And if you do a typecasting and then you dereference it, even though it was initialized as 1 byte, it's now going to point to 2 bytes. Okay. So what is happening over here is first you're typecasting P to UNT16. In that case, it's pointing to 2 bytes. And then you are dereferencing it. So you are getting the value. Okay. This creates a nameless temporary pointer that has the type of UNT16 and pointer has the same value as P. So it points to the same target as P. This does not change anything about P itself. Just by doing dereference, you are getting 2 bytes instead of 1. So this is how kind of it works. Like you can do it for 8, you can do it for 16. In that case, it's going to point to 2 bytes. If you do 32, it's going to point to 4 bytes. And if you do 64, it's going to point to 8 bytes. Okay. So that's basically your introduction to pointer. I hope it makes sense. We will get more into malloc, free, and how pointers work with arrays and all of those stuff later on. And if you have any confusion about this particular lecture, let me know. If you need more examples or understand it more, let me know. And my suggestion is try to run those codes yourself. Try to write your own code to understand it better, because the more you try codes yourself, the more it will make sense to you. Otherwise, you will have like a vague idea of how pointer works, and that is not the move. Okay, so yeah, I'll see you in the next video.